Hello class, welcome to our lesson, section 3.3. Today we're starting to talk about solving equations. So up to this point in chapter 3, we've talked about simplifying expressions and combining things together like terms. Today we're going to be starting to talk about solving for a variable, and we're going to use addition and subtraction to help us find that. I'm going to use some of the algebra tile ideas to kind of showcase what's happening here and why it's working. This should help visual learners to be able to kind of see what's happening as opposed to just seeing the numbers. So what you'll notice here is we have x minus 3 equals negative 4. X is one of the larger rectangles. Minus 3 is 3 smaller squares that are negatives, and equals 4 of those negative squares. Now the goal when we solve equations is all about getting the variable or the unknown by itself. So whenever you have to get something by itself in mathematics like this, you have to use PEMDAS, but use kind of the opposite kind of ideas. So for example, this is a negative or minus 3. The opposite of minus 3 would be positive 3. So I'm going to have to put 3 positives here to be able to cancel out the 3 negatives. But in an equation, it's all about balance. Think like a scale from your science classes, for example. When you do something to one side, you have to be able to balance it, okay, and make sure everything stays even. So if I add 3 to one side of the equation, I'm going to have to add 3 to the other side of the equation. And when I start canceling these out because they're opposites of each other, I'm left with the variable and one negative on the right side, so it's x equals negative 1. Mathematically, what we have is x minus 3 equals negative 4. To get rid of minus 3, I do plus 3 on both sides, and I get negative 1. You'll probably see me and a lot of teachers and other students write things vertically. You could also write them horizontally as well. So this could be x minus 3 and then the plus 3 next to it. It really doesn't matter which one you choose. I tend to do vertical because it's easier to kind of read in one kind of vertical statement, but it doesn't matter which option you pick. What is important though is that on all of these questions, when you go through them, the requirement is you're going to write the original problem, you're going to show the step of adding, in this case, 3 on both sides, and then x equals whatever your answer is. These questions can probably be done in your head, and maybe you've done that before, but you're going to reach a point where you're going to need your steps. So what we're working on probably is not what the answer is. It's probably, I want you to show that work as you're looking at those questions. Next one, this is x minus 5, because there's one x and 5 negatives, equals negative 4. Remember, to get rid of 5 negatives, you need 5 positives. You start canceling out because they're opposites of one another, and you're left with x equals 1. Mathematically, x minus 5 equals negative 4. You write the original problem. To get rid of negative 5 or minus 5, I do its opposite to cancel it out, which would be plus 5. Minus 5 and plus 5 go away because that's 0. You're left with x on the left side. Negative 4 plus 5 is 1 of each. So you subtract them and you get 1. These questions shouldn't take very long once you get rolling, but make sure original problem, show your step, and the answer. That's the requirement for these questions. The next one shows what happens possibly when they're the same symbol being grouped together. So you've got x minus 2, and you have 5 on this side. So to get rid of two negatives, you do 2 positives. Notice here on the left side, though, there's already 5 positives, so I just add 2 more, and that's why it's x equals 7. The other thing to notice is that this is flip-flop. The variable's on the right side instead of the left. That doesn't change the problem at all, but if it bothers you, just flip-flop them back so that it's x minus 2 equals 5. To get rid of minus 2, I do plus 2 on both sides, x equals 7, and I move on. Again, the setup is what's important here. The answer should come quickly, so that it's write the original problem, show the step, find the answer to get those credit for those questions. All right, so I'm not going to spend too much time on these scenarios. Once you see how it works, it should go fairly quick. You got z minus 6 equals 2. I need to get rid of the minus 6 by adding 6 to both sides, so z equals 8. Get rid of minus 7 here on the second one, add 7 to both sides. Notice this is 1 of each, so 7 minus 3 is 4, and it's positive because the bigger number was positive. Notice I put the variable equals. I didn't just say, oh, the answer's 4. Okay, make sure those things as you're looking at it. The next one, you have negative 15 equals t minus 5. You can solve it that way if you want. If it bothers you, flip it around and make it t minus 5 equals negative 15. To get rid of minus 5, I'm going to add 5 to both sides. That cancels out the 5s on the left, so you have t equals negative 15 plus 5. That's one of each, so you subtract out and you get negative 10 as your answer. The next question just is setting up an equation from a situation. The key to some of these questions is the word is. So a company has a profit of 750, so I write 750. This profit is, the word is equal to, and then you just read the last part of the statement and say, okay, 900 more than last week's profit P. Well, 900 more than would be plus. And so this should go back to what we did earlier in this chapter where we set up the written expressions and wrote them mathematically. And so that's why this becomes what it is. But the key is the word is means equal to in all of these situations. Next one, you spent $7.25 this week. This is, and then $3.65 less than what you spent last week. Remember, with less than, you have to be more specific. If it's something less than, like the variable has to go first because you start with that and then subtract 3.65 from it. If they tell you a specific variable, like in this case they said use S, then you need to use S. If it doesn't say what variable to use, you get to pick which variable to use. Okay, these three questions, just make sure you know what you're looking at. So here, to get rid of plus 12, I do subtracting 12 on both sides. Notice these are both negative, so you should add them together. Second one, you'll notice that the C is second, the variable, but the number is first. And you say, well, what do? It's 15. Well, that's positive 15. So 15, what's the opposite? Negative 15, or subtracting 15. And then that would be both negatives and add them together and you get negative 27. Last one is flip-flop, but you can still do the same thing. Add 21 to, or excuse me, subtract 21 on both sides because originally it was addition. And you add those things together because they're both negatives and you get negative 37 equals D, or D equals negative 37. Both would be correct in these statements. You're also going to have some questions that deal with decimals and fractions. Remember, if something starts as a decimal, work on it as a decimal. If it starts as a fraction, work on it as a fraction. The steps are all the same, though. So it's n plus 12.8. I need to get rid of the plus 12.8, so I subtract 12.8 from both sides. The nice thing about vertical work here is the decimal places might line up if you get it set up correctly. You should add these two together, and you get negative 13.1. The next one, I'm going to have to add 4 2/5 to both sides because I need to get G by itself. Probably a suggestion here is notice here that I showed my work about how I added those two things together kind of off to the side. You could also do it right there. Some of you are good at showing vertical work with decimals and fractions, but you need to probably show some work. Some people have been missing some of those things about finding common denominators. So keep that in mind as you're looking at these questions. Finally, to get rid of negative 5.47 plus k, to get rid of this negative 5.47, you have to say, well, is it negative or positive? It's negative. So the opposite would be addition or adding that same number. So here I need to add 5.47 to both sides. Notice here on the right side, this is one of each, so you should not be adding those two numbers. It should be subtracting. So I did that work here below. I get 8.72, but it should be a negative, and that should be a 2 there. So that should be 8.72. I think I accidentally wrote the wrong number as I'm looking at that. So that should be negative 8.72 as you find that final answer. Okay, for your homework today, make sure that you're looking at all of the versions of the questions. Make sure that you write the original problem every time. Every single time you're doing these problems, I don't care how easy it is, and then show your step to find the answer because what we're working on is being able to set it up and show your work. So make sure that you do that for your homework as you're looking at today's lesson. Have a good day, everybody.